same gradient.
Yeah.
So what is the gradient of this line?
I'm not sure.
So it's always in the form y equals mx plus c.
Yeah.
And the gradient is m. And so gradient for this line?
3.
Yeah. And so you have to write the equation of some other line with the same gradient.
So you could just do y equals 3x minus 6.
Yeah. How about the next one?
Y equals 5x plus 9.
Yeah, that's fine. Okay, how about this?
Train B stays at a constant speed, while train A is constantly accelerating.
Yeah. Okay, how about this?
It takes the. Can you just say it takes the lorry 1.4 minutes to travel 1 mile?
Other way around.
It takes the train 1 minute to travel 1.4 miles.
Yes, and this one is kilometers.
Yeah.
1.4 kilometers. So basically it's traveling at 1.4 kilometers per minute. Larry travels 1.4 kilometers each minute. Let's see. How about this one?
I could just say it takes every hour you go down by 4 centimeters.
Yeah.
Or depth decreases by 4 centimeters every hour.
Yeah. By 4 centimeters. Okay, fine. Let's see this one. All right, how about this?
The container Q will empty first, right?
What time will it empty at?
Well, Q empties 2 liters every 10 seconds, roughly.
And what time does it empty at?
Empties at 40 seconds and one empties at 50, so P empties first. Sorry, so P empties first.
Yeah, P empties first. And a reason for your answer, like at 40 seconds or something, or after 40 seconds.
Yeah.
Okay, how about this?
Train A is traveling at a greater. Sorry, train. Yeah, train A is traveling at a greater speed.
And why is that?
Because train A travels more distance in 30 minutes.
Travels greater distance
In 30 minutes than train B.
Yeah, okay. And C, this last one.
Is it 15 minutes?
Yes, I believe so. I believe there's a difference of 10 there. So 15 minutes. That's it there. Okay, what's this?
So £5 is $8.
Yeah, so there's a million of those questions. Just use your ruler and do it as accurately as possible. Sometimes it's halfway, sometimes it's part of the way. You're gonna be fine for these. Okay, how about this?
At 3 p.m. he rested for 30 minutes. And Simon at 5 p.m. was 20 km from home. 20 kilometers from his house.
Yeah. I think I'll be fine here. I think I'm fine. How about this one?
Well, the cost in pounds is £80 at 55 cubic meters of water.
Do you know what I mean by fixed standing charge?
Do not.
It would be how much it would cost even if you used zero.
Oh, £15.
So I can see it maybe a bit closer up than you. I think it's 14, but yeah, you have the right idea. I think it's like 2 squares out of 5. Okay, these ones.
The coordinates of point. I'm not sure how to do these.
So one trick is that they repeat every 360 degrees, and so that's 360.
Yeah, I get that. I'm not sure how I meant to. Wait, would it be P is 180?
Yeah, and y coordinate?
Where was the Y?
Like what is the y coordinate?
Oh, 1.
That would be up here. If it's on the x-axis.
90.
Y coordinate is just 0.
Oh, right, yeah.
It's on the y. How about Q?
270.
Yeah, and do you know the y coordinate?
You said it was 0.
Oh, it's down lower than that.
Oh, -1.
Yeah. Okay, cos graph. How about A?
A is 90 degrees.
Y coordinate?
Y 0, right?
Yeah, that's it. Got it. Okay. 3D coordinates. Let's try it.
I do not know how to start these.
So it's literally just 3D coordinates. Like, let's see. 3 of the vertices. So 3 right. So on the X, that must be 3 right. On the Y, that must be 2 up. And on the Z, that must be 4 along. So Q is 300, and he idea where that would go?
Would it be just I'm not sure.
So it's 3 along the x. So you start from the origin, 3 along on the x, 0 on the y, and then 0 on the z, and so it's just there. It's just 3 along. Any idea about the coordinates for S?
Well, that's 2 up.
Yeah. So where does the 2 go?
In the middle.
Yeah.
It is 3 across.
Which one?
Right. It's at the start. So the first one.
Yeah.
And then I'm not sure how many up it is. I'm sorry. Is it? And then it's not 4, is it?
Yep.
Or is it? All right. Yeah.
So if you go 3 on the x, 2 on the y, and 4 on the z, that's where you get to it. Okay, let's try this one here.
Coordinates of PR 5, 3,
Yeah.
4.
Yeah, I believe so. And next one. Oh, sorry, I have it up here.
Would that be that 0?
So you start from 0. So it's the coordinates 0, 3, 2. So you have to put your own point.
So it goes 7 across, it goes 3 up.
Yeah.
And then is it midway across?
Yeah.
Yeah.
And that is the point C. Great. Any questions there?
No.
Okay, coordinates of R.
So wait, is this counting from the O?
Yeah, so the O is always 0, 0 or 0, 0, 0.
So that's going to be 0 at the start because it's going none across. 2 up, and then I'm going to guess 2 down. So 2 like across.
So I'll be halfway with it.
Is it 4 then?
Yeah, I think it would have to be 4. The vertex N has that. That's 6, 2, 4. So this would be 0, 2, 4. Yeah, it has to be 0, 2, 4. Because it's straight across from the N. Yeah, so instead of 6 on the X, it's 0 on the X. That's it. Okay, how do we do this?
Isn't just the circumference just pi radius squared?
That's area.
I'm not sure what the circumference is then.
Pi times diameter.
So pi times 9.
Oh yeah, so this one down here, so 9 pi.
So it's like 3, yeah.
Top left one.
The diameter you've got, so it'll be 8 pi.
Okay, that's 8 pi. How do we do this one on the right? Lighthouse Harbour thing.
Um, I don't know how to start.
So you have to say which angle it is that you have to find. Measure the bearing of H from L. So of H from L is the same as from L to H.
Yeah.
So L to H. So the way bearings work is you point north, turn clockwise, and stop when you hit the line. And so what angle are we trying to find?
H. Sorry, LH.
So it's the one at L. So from L to H, and so it's this one. And so you just measure that with your protractor. How about the one on the left?
Would it be? So it's from L to Y. So it's from Y to L.
Yeah.
So you draw a line from Y to L, and then you measure that angle there, the bottom one.
Yes, and there's kind of a trick to this. Let's see. So you line your protractor up. So north is 0. So the cross goes on the X at the bottom. So it starts from 0. And so what does it look like the angle is?
50.
So that's 50 degrees. And do you know how you write a bearing angle?
Do you write the opposite?
No. The trick is you would have to write it to 3 significant figures, and so you have to write 0, 150 degrees.
Yeah, I've seen that before.
So that's just a little weird thing. Okay, let's try top left
one. AB in terms of A and B is minus A plus B.
Great. How about the one underneath it? No, how about the bottom right one?
Is it minus B plus A?
Yeah, I think you're gonna be fine. How about the one on the left?
Is it OT in terms of A and B? A plus B.
And part 2?
Minus A plus 3B.
From P to R, yes. Minus A plus 3B. I think you're going to be fine for all these. How about the one on the left?
Is it minus 3B plus 2A?
Not 2A.
Plus A, sorry.
Yeah. Let's try this hexagon up here.
Okay. So are we doing AB?
Yeah.
Minus 6A plus 6B.
Okay. How about part 2?
EF. Is that minus 6B plus 6A?
So is there any vector that's the same as e to f?
Not sure.
O is the center.
Oh.
So is there any line that's the same length, same direction as this?
AB is the same.
AB is different direction. It's going this way.
So DE.
D is a different direction, like a parallel line.
Oh, CD. Right. No, I'm not sure.
So C to B is parallel.
Oh, yeah.
But we don't know what that one is. Is there any other line? Parallel.
I'm not sure.
O to A. So it's the same length and same direction.
Yeah.
And so what is that?
O to A is 6A.
Well done. Let me just see something for a sec. Okay, better do it. Bottom right.
CA is just A, isn't it? C to A is, oh no, C to A is minus B plus A.
That's B to A. C to A.
Is that just?
And O is the center. It's the midpoint.
Is that two? Is it 2A?
Yeah.
And B to C is minus B minus A.
Well done. So this one, yeah. So solve this one up here. So it's just a quadratic.
Yeah, I'm really bad at these.
So x minus 2x plus 3 equals 0.
Is this functions?
Yeah, what if it was just a quadratic?
If it was a quadratic, you could just put it into the formula, couldn't you?
Like, just by looking at it? X minus 2x plus 3 equals 0.
X equals 2 or 3.
Yeah, or 3. So that's the f of x equals 0. If it becomes the f of x plus 7, what happens is instead of x equals 2, it's x plus 7 equals 2.
Oh, yeah. Yeah, I get that.
And so what's the new x then?
Minus 5 or minus 4.
Yeah. Hang on. One of these was negative. That should have been minus 3, sorry. So that's minus 3. Minus 7, minus 3.
Yeah.
What is 7? Minus 7, minus 3?
Minus 10.
And so what has happened from 2 became minus 5, minus 3 became minus 10. What has happened there?
I'm just done at 7, haven't I?
Sorry?
Isn't it just all because of that 7 that they've added in?
Yeah, so what happened to each answer? 2 became minus 5. What happened to the...
They added, though, they took away 7.
Yes, and so the difference between the f of x and the f of x plus 7 is it's subtracting 7 from all the x's. And it'd be the same thing if it was f of x minus 7, then I'd be adding 7 to all the x's.
Yeah.
Okay, how would you do part A for this one? No, sorry, part C.
Since the f of x is the opposite of x, right? So it affects so it goes backwards. So you would move the graph to the left, I want to say.
Yeah. How about part D?
We'd move the graph 4 to 4 to the right.
Yeah. And do you remember how do we do part A?
That's just moving it up by 1, isn't it?
Yeah, well done. So I'll move up to there and so on. These are similar. Okay, exam question.
So you keep on moving you keep on moving the graph down by 3 because that's what it says to do. So the first step would be from going. Is it at point 4 right now?
Yeah.
Is that what I'm trying to say? So you do that -3, which is 1, and then down to -2.
And so what is the coordinates now of where it meets the y-axis?
Is it -1?
Yeah. As a coordinate though?
1. Sorry, 0, 1. Or 0 -1.
Which one?
0 -1.
So that will be down here.
Oh, 0, 1.
Yeah. So 4 take away 3, 1. Okay, how about this?
So the y of f of x plus 3, that means it's going opposite, so you're moving the x by 3 to the left. So that's the maximum curve. So it would be 0, 5.
Yeah. And part B.
That's moving it down by 4, I want to say.
Right.
So describe the transformation. You just do bracket 0 -4.
Well, what type of transformation is it? Do you know?
Translation.
Yeah. And how do you say 4 down?
-4 or 0 -4 and like on top. Yeah.
Yeah.
Like that.
That's it. Gonna be fine for this. Fine. Fine. What would you do here?
Would you do? So it's sin x plus 2. So do you just move it across by 2?
That would be if it was in a bracket next to the x.
Does it go up by 2 then?
Yeah, everything goes up by 2. So
Yeah.
every point.
That 90-degree point would be on 270. The 180 would be on. Yeah, you just move it all.
Just move them all up by 2. There we go. Okay, how about this?
Would it be y equals f bracket x plus 6?
So this is the original one.
Yeah.
And it moved 6 to the right?
Yeah. So isn't that plus? Sorry, minus
Yeah.
6.
Yeah. Let's see. How would you do this one?
Wouldn't you just move the 1 down to -1?
Yeah, and so on. How about this one, the minimum?
That would go down to -2. No, sorry, that would go down to -3.
So this is y equals minus cos x. So what happens here?
Doesn't the x just go down?
This one changes all the signs of the y's. So +1 becomes -1. What happens to -1?
Becomes 0. Oh, sorry, it becomes 1.
Yeah, it becomes +1. What about the y's that are 0?
They stay at 0, don't they?
Yeah, and so it's like a reflection.
Yeah.
In the x-axis. Okay, how do we do this?
So for part I or part A,
Yeah.
wouldn't you just do that? You just swap around the signs, right?
Yeah. So let's say this minimum, where would that be?
That's at -1, 4. Sorry, -1, -4. So you just reflect that. So it's 1, 4.
So that would be like a double reflection.
Yeah.
No. There's only one minus. So it's either going to be a reflection of the y's or the x's.
It's going to be otherwise. So you only reflect the -4, -3, -2, -1, that bit.
So let's say, so the minimum is currently at -1, -4. So where will it go to?
1, 4.
So you've reflected both the x and the y there.
So -1, 4.
Yeah. -1, 4. Let's say this point here, 2, 5. Where's that going to go to?
2 -5.
Yeah, 2 -5, and so on. I'll go there. Okay, how about part 2?
Just do the exact same, except you do it in the x-axis instead of the y-axis.
So where would be the minimum?
So -1, -4 becomes 1, -4.
Yeah.
And 2, 5 becomes -2, 5.
Yeah. And so on. Okay. Okay. That one's okay. Okay, let's try this.
So G is just G equals Y. G equals -y bracket x.
No. So what happens to y equals the g of x?
I guess inverted.
And how do you show that?
-gx.
Yes, that's it. Okay, how do we do this one?
Do you just move it up? Do you just move the everything up by 2?
That would be +2. This is ×2.
Oh, so you multiply the 1 by 2, right?
Yeah.
To get 2. So everything just moves up by 1 step.
Well, let's say the -1. What is -1 times 2?
0. Oh no, sorry. -1 times 2 is -2.
Yeah, so that's stretched down. So this is a stretch.
Yeah.
And then the 90 one.
Stays at 0.
Yes, that's it. So this is a stretch. And looks like that. So how would we do the first part?
Let's move the y-axis up by 3.
So it's now about 3. Okay. How about this bottom one?
This moves up by 3 as well. But it stays in 1, the 1.
You're thinking of a translation. You're thinking of +3. This is ×3.
Oh, does it go up to 3?
You're thinking of +3. So it's current. What's its current y coordinate?
3.
The minimum
1.
y coordinate.
I'm not sure.
So what's the coordinate of the minimum?
3, 1.
No.
0, 1.
So 1 0.
Yeah.
Okay.
Oh.
So like, okay. So, what will that become?
4, 0.
So you're thinking of if the 3 was in a bracket next to the x.
9, 0.
So this is in the y direction.
I don't know.
So you're multiplying all the y's by 3.
Oh, 1, 0. It's all the same.
So that one's saying the same, yeah. Okay. Okay, how about this one?
The x goes down by 2, or 2 to the left.
That would be if it was +2. This is ×2.
Okay, they get divided by 2.
Yeah. So let's say the minimum. Where would that be?
Minimum x is 1, right, or 0, but that would stay the same.
Like the minimum is this point at the bottom.
Oh, 2 divided by 2 is 1, so that moves 1 to the
Left, yeah, that's it. Okay, and then how would you do part B?
You're doing a third of the x.
Say it again, sorry?
You're doing a third of the x, right? But do you actually just multiply it by 3?
Yes.
So the minimum would be on 6.
Yeah, that's it. Okay, we're good for those. We're good there, I think. And then these are just, yeah. Okay, so that's geometry. So 1 mark data. Let's do something that's worth doing. So how about this one on the right?
So you just draw 4 jars.
Yeah. And part D, the last one.
5 more jars.
So let's see. 4 then week 3. Yeah, 5. Fine. I'm happy for all these. So it's a very common question, but it's easy. Okay. 1 on the left.
Most boys chose to go climbing.
And part C.
Just draw up a girls box up to 7.
And how do you show that it's girls?
It's got the line in between the bar.
Yeah. How about this one over here?
The mode is 7 marks.
Yeah. Okay, how about this?
Lauren is correct. No, she's not correct. Because the girls, actually, wait,
What would you say?
Because we don't know the number of them.
Yes.
The overall number of people in the bottom pie chart.
Yeah. Pie charts show proportion, not population.
Yeah.
So I'm just copying the mark scheme. That's what that said. There's no information about the population. Okay. Okay, top left one.
56.
No, that's the height of the tallest one.
Oh, 1, 2, 3, 4, 5, 6. 18.
I think it is. Yeah, 18. That's fine. How about the bottom one?
The greatest height is 68.
This one, top.
The mode is 17.
Yeah. Range?
46.
How about the top right one?
7.
Yeah. Top left one.
Median height 1, 2. 66.
And what position should the median have for this one?
Shouldn't it be in between 66 and 67?
The way you do it is it is a half of n plus 1. So n is 15.
Which is 7.5.
So it's n plus 1, and then you half it.
Oh, 8.
Yeah. And so which is the 8th one?
67.
Yeah. And so basically that one, the 8th one, it has 7 before it and 7 after it.
Yeah.
So that's a quick way you can get it. How about the bottom one down here? What's a quick way of getting that one?
N is 25.
Right.
Plus 1 is 26.
Mm-hmm.
After that's 13, so it's 13th number.
Yeah.
44.
That's it. Yeah. 44 or whatever miles per hour. Okay. Top one.
Is it 34?
How did you get that?
That just did the range.
No. Modal class interval means the mode.
Oh, so 60, A, 80.
Yes. And so the bottom one?
160, H, 180.
Yeah. I'll just do one of these. Top left one?
The population of village in 1991 was 8,000.
Yeah.
The 8 was 2011 was 4,000.
Yeah, fine. And again, millions of those. Okay, how do we do this?
So you go to 22k
Mm-hmm.
and go up to 50 minutes and just draw the X where the two lines meet.
Yeah. So lots of those. How about this one?
Oh, 45 minutes, right?
Yeah. Sorry. Okay, how about this on the left?
It's a proportional relationship or a linear relationship.
Yeah, and so in just a more
Increase in width equals increase in length.
yeah, and so what is yeah, correct. So I'd say so as length increases, width increases.
Yeah.
Yeah. Okay, how about the one on the left here?
The higher the rainfall, the more umbrellas sold.
Yeah. Okay, how about this one?
So it's a positive correlation.
Yes, well done.
And the longer the distance the driver has to travel, the longer he would take.
Yeah. This one?
Negative correlation.
Yeah.
The higher the engine size in litres, the less number of miles will be required.
That's good. That's good. How about this one?
D.
Yeah, sorry. It's kind of a weird one. Hang on. How about this?
On 8 degrees, around 20.
So draw a line of best fit.
Yeah.
How do you draw a line of best fit?
You connect the bottom and top.
So you draw so that you have the same number above as you do below.
Yeah.
So I'll draw it like that. So I've got 3 above, 3 below. Is that right? Yeah. And okay. So now using the line of best fit, how would you do the 8 degrees one?
I'd put it at around 22, 23. 4.
Let's say 24. And you'd use a ruler to try to do it as exactly as possible. No. This one. Yeah. Okay. How about this?
To draw a line of best fit first.
How do you draw it?
You go from the bottom, the most left point to the most right point.
Right.
Make sure they're both connected.
No.
So now then.
Should have the same number of x's above as below. So try to make it in the center of all the data, but the first and last don't necessarily need to join up.
Okay.
And then the 2.8 one.
2 around 30 miles.
So it looks like it's pretty close to 30. Oh, it's maybe a bit more actually. Maybe 31. Yeah, 31. Yeah, and so we've gotten about, so next is box plots. So we got about halfway. So we did all of 1 mark geometry, half of all 1 mark data. How was that for you, James?
It was good, thank you.
Anything in particular you want to do next time?
Not really.
So I might just finish this 1 mark and then do the 2 mark questions for each one, so you just get a mixture of all of them. Any questions for me in general?
No, not really.
All right. Well done, James. You did great. I look forward to talking again next time.